Here we go. This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, be appropriate, and please participate. Please, however, do not share personal information during class, such as contact information or social media information. For your own security reasons, we don't want to share those things during class. Ireland, you've been doing horse riding for 11 years. That's amazing. I'm sure you are very strong then. Okay, so I am Mrs. Larkin. I know we have a couple new students in class today, so my name is Mrs. Larkin. This is my email and my phone number, so if you need to email me, emailing is usually the best way to contact me. Calling and texting is sometimes a little bit more difficult for me because then I have to get some links and stuff off of my computer and then put them on my phone, and that can be a little bit harder. So emailing me is usually the best idea unless it's something super immediate. Just so you know, new students, you do get 5 attempts on every assignment. So just kind of leading up into that, want to let you know that. We are officially in week 3, everyone. So we're in day 10 of the quarter. There are only 35 school days left of quarter number 3. Again, it does go by quickly. So this unit, we're talking all about different forces and gravity. We're going to have a lab on Wednesday. It's actually a really good lab. It's pretty fun, the virtual lab, and the actual answers, you have to draw the answers. So we'll do that, and that's pretty cool to play around with as well. No, Israel, it's definitely not. It's not hard. You just, like all labs, it takes a little bit of extra time. So you just got to meet me halfway and do what you got to do to get those done, because they are big, big grades in your report. Oh no, it doesn't require being good at drawing. You just have to be able to draw some boxes and some arrows and stuff. Don't worry. It doesn't require any artistry. And then Friday we will be starting our 4th unit. So that's where we are going this week. So again, we do have some new students starting today. They're called our cohort 2 students. So let's see here. I think I recognize some new names, right? Let's see here. Miguel and Michelle, I think. Right, I think you guys are new. If you're not, let me know. But we do have some new students, so go ahead, give them a round of applause from your smiley face menu. Go ahead, let's welcome them. We're excited to have some new students with us today. So just so the new students know, you do have a survey that is just for you because you're starting this week. It's called the Welcome to Physical Science Survey Late Start Students. I do have it open all week long, so as soon as you find some free time, please go ahead and complete that survey. I'll go ahead and link it to you right now. Here we go. So here's the link to it. Again, that's only going to work for our late start students. So if you started 2 weeks ago, you can click on it, but you won't be able to see anything. So again, only late start students, there's the link to that. And again, you can finish it anytime this week. If you're a late start student, please be aware that you are excused from the first 2 weeks of quarter 3. I know, isn't this cute? Catch up. So if you're a late start student, you are excused from the first 2 weeks of material, but keep in mind that that material will still be on the midterm and final exam. So if you do feel the need, you can actually watch some of the old recordings if you want to catch up on any of that material. So you don't have to do any of the assignments, but I do recommend if you want to get caught up on things, you should watch the recordings just so that you can kind of review that material. Okay, here we go. Let's keep on moving here. So at this point, we should have our attendance ticket open. I see lots of green checks letting me know that you've got that open and ready to go. Here we go. Here's the link to it as well. Password is in the chat box. Again, new students, please be aware that the password is only provided in person at the live class. So if you miss an attendance ticket because you're not in class, you won't be able to complete it later with the recording. Every other assignment you can do with the recordings, so labs, exams, quizzes, game day assignments, you can make all of those things up later. The only thing that you can't do is the attendance ticket, just because that's an Insight policy. Okay, give me a smiley face, everyone, if that makes sense. If you want me to screen share the attendance ticket, please let me know in the chat box. New students, but I think all my new students actually got it open, so I think we're good. Okay, so again, just have it open, ready to go. You don't need to do anything with it yet. I will be giving you the answers throughout class, so you will get all of the answers throughout class. Cool. So again, new students, just a reminder that All assignments, we do actually complete them during live class sessions. So the course is really easy if you just attend class. Come to class, you get everything done, and then after your 45 minutes of being here, you have nothing else to do for the day. So it's super easy. It's like less than 3 hours of work per week to get everything done just by coming to class. Okay, if you don't come to class, then you have to do it on your own time, and that takes a little bit longer, and it's just not quite as convenient, right? Again, attendance is 10% of your grade. You do have to actually attend to get that password. It won't be in the recording, okay? Again, if you have something like a doctor's appointment or you work during class times, definitely email me. We can work something out. But right, in general, this is the policy, okay? Now, I do want to remind you that you do need to be doing labs and quizzes. This is an important reminder even for my old students. Labs and quizzes do make up 65% of your grade. So if you're not doing them, you're definitely going to have a hard time passing class, okay? So we have support sessions as well. Okay, yes, absolutely. No, Tariq, I think we already set something up. But yeah, you can definitely email me back. I think I've emailed you a couple times around that about that. But you can definitely email me and I can let you know anything that you need to know. Okay, Tariq? Thanks for letting me know. Cool. All right. So this is our current schedule. So you are last names N through Z. So we have class every day at 12 o'clock. And then Tuesday, Wednesday, Thursday, there is support. So 10 a.m. Tuesday, Thursday, 2 p.m. on Wednesdays, just for a half an hour. But really, you just need to show up. And if you show up to a support session once per week, you'll get some extra credit. So there's a little form that I have you fill out to look at your grades and figure out what your goals are for the week. And then you can get some extra credit. And it's super fast, takes 5 minutes, maybe 10 if you work a little bit slower on it. But it's really, really fast. Give me a smiley face if you've done this already. Tell me in the chat box, how is it, right? It's super easy to do these. Yeah, and it's easy extra credit. So definitely come to support if you want some extra credit, as well as support, right, if you want some help. The most important tip for my new students is that the gradebook is where you can find everything that you need. The links to the assignments as well as the recordings that go over all of the answers to the assignments are in the recording. Again, you can turn anything in even if you're not in live sessions except for the attendance tickets, right? So if you are missing a lab or a quiz or an exam or you missed a game day, there's always an alternative assignment. You can complete those anytime. They are in the gradebook. Okay, so let me send that link to your gradebook let me send you the link to the gradebook. It's also really easy to find on the home page. You can see, awesome. So on the home page, it's just where it says grades. Hi, Andres, how are you doing? Okay, give me a thumbs up, everyone, if that makes sense, especially my new students, thumbs up if that makes sense. The grades is the most important tab in the entire page, at least for my class. It might be different for other teachers, but I try to put everything in one spot so it's really easy to be as successful as possible. Cool. All right, so let's go ahead and actually jump into today. So today we're talking about applications of forces. So this unit we talk a lot about two main forces, friction and gravity. And we also talk about this concept of vectors, which vectors are the way that we actually show what forces look like on paper, right? Because in real life we don't see forces, right? They're invisible. But in diagrams we need to be able to demonstrate what they look like. So we use these arrows or what we call vectors in science. And that's actually what a lot of your lab is about, which is why you'll need to be doing a little bit of drawing for your lab report on Wednesday. So our objective for today, we should be able to identify the different types of friction. There are two main ones that we're going to talk about. We're going to explain the factors affecting gravity, and then we're also going to try to differentiate between mass and weight. I've mentioned a couple times in the past, mass and weight, we often use them as synonyms, but in physics, in science, they actually are slightly different from what we define them every day, okay? So here we go. Let's go ahead and first talk about friction. So friction force is a force that opposes the motion of an object. So for example, this object is trying to move to the right, so friction is going in which direction? It opposes it. It goes the opposite way. Tell me in the chat box, if the box is trying to go to the right, the friction goes which way? I got an answer from Arrow in the chat box, everyone. Please participate. I see Andres typing. I see Shoshana typing. Thank you. Yes! Sorry, Andres. I did send it to you right as you got into class, but I don't think you might have seen it, so let me grab it again. Here we go. Yes, so friction goes the opposite direction and goes to the left. Awesome. Now, let's go back and think really quickly. We're trying to put this all together. No problem, Andres. We're trying to put this all together. So remember back to Newton's first law from last unit. An object in motion will what? Tell me in the chat box. An object in motion will what? Tell me in the chat box. We learned this last unit. This was Newton's first law. Yes, exactly, Ireland. Exactly, Arrow. It will stay in motion. An object in motion will stay in motion unless it's acted on by an external what? It's going to stay in motion unless what acts upon it? Yes, unless a force comes in and starts acting upon it. So this is actually why objects on a surface don't move forever like they do in space, right? We talked about how in outer space there are no external forces. So once an object starts moving, it's going to keep on moving in that direction forever and ever, which is why astronauts need to be very careful the direction that they move in outer space. But on Earth, we don't need to worry quite as much about that because friction is in fact an external force, right? Friction force is a force, and friction force works on almost every object on a surface in our friction force is an external force, and this is the external force that is changing the motion. It's actually slowing them down. Give me a smiley faces if that makes sense. Right, so Newton's first law, we often don't see it in work in real life because friction is there. There is an external force, and that external force is friction. That's why we don't always see Newton's first law in real life. Awesome. Okay, now think about this. If an object has more mass, do you think surfaces are going to press together more or less? Tell me in the chat box. If a surface has, or if a object has more mass, do you think it's going to press down harder or lighter onto a surface? Yeah, it's absolutely going to push down more. So more mass, surfaces press together with more force. And so the result is you actually have increased friction. So we can see this right here. Take a look here. Imagine we have something super light, and you can see it's not pushing down very hard. So this is a zoomed in picture of our surfaces, and you can see they're rough surfaces, so that's where the friction comes from because they're not perfectly smooth. But if it's a light thing, it's very easy to push over the surface because it's not digging down into those crevices. With a heavy load though, the heavy load actually pushes down a lot more, and therefore it's much harder to push it across. So in real life, our application is this would be like pushing a, let's see here, what's something light that we can push? This would be like pushing a, I don't know, give me an idea, guys. This would be like pushing a Amazon box across the ground, whereas this over here is like pushing a refrigerator across the ground. Give me a smiley face if that makes sense. Okay, so something light has less friction, something heavy has much, much more friction. Yeah, of course, exactly. It should make sense, right? But we got to make sure that we have the vocabulary to express this. Awesome, so let's go ahead and make sure we understand this. I'm going to give you polling tools, so your green checks just turned into polling tools. Yes. So tell me, increasing the mass of an object, what happens to friction? Is it the same amount of friction, increased friction, decreased friction, or no friction? Use your polling tools. Tell me, what do we got? I see answers popping up. All right. Yeah, no worries, Cash. Let me know if you didn't get the ticket. Ticket's in the chat box. Thank you for getting here, though. Awesome. Okay, I'm going to go ahead and publish these really quickly just so we can see them on our board. Yes. Thank you, Andres. All right, so taking a look here, looks like most of you said letter B, and letter B is true. So more mass, more pressing together harder, which means it's going to be harder to move. Increased friction. Excellent job. All right, everyone. So this is the answer to number 1 in your ticket. All right, so again, the link to your ticket's in the chat box along with the password. Please answer number 1, all right, increased friction, and give me a green check when you have number 1 saved. I'm going to give you 30 seconds. Everyone, give me some green checks. Ready, set, go. Looking good. All right, let's get some more green checks. Amir, Ashton, Bradley, Danny, David, Donnie, Edwin, Ethan, Ireland, Joey, green checks please, Cash, Matt, Maxine, just want to make sure everyone's here, Nate, Razi, yes, exactly, Andres. Awesome. All right, let's keep on moving here, everyone. So there are 2 types of friction that we need to talk about. I know I'm actually at a friend's house, so this is not my house, so you can see that here. So there are actually 2 types of friction. The first type is static friction. So the word static means to stay, right? So static friction means things that stay in place. Okay, think about like static electricity. Static electricity is the electricity that builds up in your body and stays there until what? Yes, exactly, Andres. What happens with static electricity? Eventually you can tell me, to your younger sibling or your older sibling, what happens when static electricity builds up in you? Yeah, you can actually shock somebody. So again, static means it's staying in place. So static friction is the same way, where it means it's the resistance force between objects that are staying in place. So they're non-moving. Smiley faces if that helps you understand that definition. Static, non-moving, staying in place objects. Okay? Now, this is like, for example, again, think about that really heavy refrigerator, or think about a car. Have you ever tried to push a car by yourself? Do you notice how when you start pushing the car, it takes a while before it actually starts moving? Does anyone know what I'm talking about? Or have you ever tried to push something really heavy and you weren't able to push it at all until you got some help? Yes, exactly. So this is exactly what's happening. When an object is at rest and you can't push it, it's because static friction is preventing you. Static friction is working against you. So it's preventing this object at rest from moving. It's keeping it at rest. So before we can start moving the object, we actually have to overcome static friction. We actually have to be stronger than static friction. Give me a thumbs up if that makes sense. So you have to be stronger than static friction before the object will begin moving. Awesome. Thank you. Thank you, Arrow, Shoshana. Looking good. All right. Now, kinetic friction, on the other hand, what does the word kinetic mean? We should probably be able to think about this. Static means stay in place. Kinetic, what do you guys think that means? Okay, we've used the word kinetic a few times. All right, so what does the word kinetic mean? Think about like kinesiology in college is the study of the body's motion, right? What does kinetic mean? Yeah, think of Xbox Connect, right? What's happening in that, right? Xbox Connect, right? They're looking at you and they're looking at your motion or your movement, exactly. So kinetic means movement. So just like static meant that it's the friction between non-moving things, kinetic means the friction between things that are moving. So this is why, for example, again, thinking back to cars, can you just press on the gas once and keep on moving forever? Can we press on the gas once and then just take our foot off the pedal and move forever? No, because then gas would be really, really easy for us. No, instead what's happening is the road is actually slowing you down. So there's friction between the car and the road as it's moving that's resisting your motion. Yes, gas would be irrelevant. Yeah, in that case, you might as well just push the car by hand and then just jump in and you would move forever, right? So kinetic friction is the force that resists the motion while it's sliding across a surface. Yeah, exactly, Caleb. So for example, if you're going downhill, right, there's actually gravity that's helping you overcome kinetic friction and keep you moving. So kinetic friction tries to slow you down once you're already moving. So static, non-moving, keeps you from moving. Kinetic, you are moving, but it's trying to stop you, Okay, let's make sure that that makes sense. So taking a look here, what do you guys think would fill in these blanks correctly? I'm going to go ahead and send you or change your polling tools. So which words would fill in these blanks correctly? Blank friction prevents an object at rest from starting to move, while blank friction resists the motion of an object that is already moving. Which of these do you think would correctly fill in those blanks? Correctly fill in the blanks. I think this one's at rest. This one is moving. That should help us give us some hints about what goes here and here. All right, I'm going to go ahead and publish our responses up here. I see lots of answers. Love it. Here we go. So it looks like most of us put letter D, and letter D is in fact very correct. Yes. Yes, it's not for me though, because again, I don't live here. So here, this would be static friction, whereas over here, this would be kinetic friction, right? Static friction between things at rest, kinetic friction between things already moving. All right, so this is number 2 in your ticket. I'm changing your polling tools back to green checks. I do need a green check when you have number 2 saved. You have 30 seconds, green checks all around. Let's go. All right, waiting in a few more green checks. Amir, Ashton, David, let's see here, Dree, Hope, Joey, Let's see here. Cash, Matt, Maxine, Michelle, Blossom, Rosie, green checks for number 2. Let me know if we're all set. Red X's if you're having any issues. All right, let's keep on going. All right, so the last thing that we need to talk about a little bit more is gravity. We've actually talked about gravity a number of times, so we should be becoming familiar with this, but in physics, gravity just has such a big role that it is in a lot of our units. So again, gravity is the force an object exerts on another object based on mass. So anything that has mass has its own gravitational field. Again, remember, you and I actually exert gravity on each other. So no matter what, remember, we are always technically gravitationally attractive because we always have a little gravitational field that is attracting other things to us. But again, we're just not as attractive as the Earth because the Earth is just much more massive than us. The more mass, the more attractive you are. Okay? Now, let's think back to this. Mass is the amount of matter or stuff that you are made of. Now think about this. If you are on Earth or on the moon or in outer space or anywhere in our universe, are you always made up of the same amount of stuff? Does your body ever change the amount of stuff it's made up of? Are you always made up of the same amount of stuff? Tell me in the chat box. Yes, you are attractive. Exactly, Andres. You are gravitationally attractive. Tell me, again, no matter where we are in the universe, are we always made up of the same amount of stuff? Well, then you would have more mass and you would be more gravitationally attractive. Yes, exactly. No matter where you are always made up of the same amount of mass, right? So on Earth, you might be 50 kilograms. On the moon, you would still be 50 kilograms of mass. On Jupiter, you would still be 50 kilograms. Floating in outer space, you would still be 50 kilograms of mass. Yeah, so you can only, you can change it by like physically gaining mass, but if you were just to magically disappear and reappear in a different place, your mass would not change, right? So if you move in an instant, your mass would not change, okay? Now, your weight, on the other hand, is going to change. Your weight is actually due to the force of gravity on that object's mass, right? So weight is actually a combination of mass and gravity working together. Smiley faces if that makes sense. So weight requires both mass as well as the gravity, which is why we can say in outer space we float, because in outer space there is no force due to gravity, and so it's not pulling your mass down. Okay? So again, even though you're still made up of the same amount of stuff, you can float because you're weightless. Okay, so you can see this over here, weight or the force due to gravity, W for weight, Fg due to force to gravity. They're the same thing, they're synonyms. Weight and the force of gravity are the same. This is what we measure in newtons because it's a force, right? Forces are always measured in newtons. Mass is in kilograms, and the acceleration due to gravity is measured in meters per second squared. So the equation for the equation for weight is actually still F equals ma. It's just F due to gravity equals m times the acceleration due to gravity. So this is the Newton's second law that we already learned, so this should actually look familiar. Smiley faces if that's starting to make sense. All right, so this is Newton's second law, which was F equals m times a. Okay, so it's actually the same exact thing, just with gravity. Perfect. Okay, so again, mass and weight are not the same. Mass is the same everywhere. Weight changes based on the acceleration due to gravity. So on Earth, we have more gravity, so we're heavier. On the moon, we have less gravity, so we're lighter, right? But your mass will always be the same. Your mass will always be the same because this astronaut is still made up of the same amount of stuff no matter where they are. Okay. Now, the interesting thing about gravity is one of the forces in our universe that does not rely on any other forces to exist. So gravity is inherent to the universe because it only relies on things having mass. So as long as you have mass, you have gravity. And since it's a basic force in the entire universe, this is what we call a fundamental force, almost like an original force. It is the force. The force. That's why gravity is so important, right? When we say the force be with you, really we're just talking about gravity. Okay, smiley faces if that makes sense. If someone were to say that in physics, we would really just be talking about gravity. Okay, so gravity is a fundamental, basic force in the universe. Okay, let's make sure we understand this. Go ahead, grab your whiteboard tools. All right, which of the following is not true about gravity? Which one is false? Which one is false? Go ahead, use your polling tools. Which one is wrong? Which one is wrong? A, it's determined by an object's mass. B, it's a fundamental force. C, it's a factor in weight. D, it is higher on the moon than Earth. Which of the following is not true or false? Which one is false? Which one is wrong? Awesome, getting lots of answers. Make sure you're participating, right? This is for your learning, right? If other people are learning, that's fine for them, but it doesn't help you unless you are also participating and challenging yourself to learn as well. Looking good. All right, getting lots of answers. I'm going to go ahead and publish these on the whiteboard. Love it. Thank you for your participation. So it looks like here we are mostly saying D, and D is true, right? If gravity was higher on the moon, would we be heavier or lighter on the moon? If gravity was higher on the moon, would we be heavier or lighter on the moon? Yes, if gravity was higher on the moon, then we would be much, much heavier on the moon, which would mean that those astronauts on the moon would not be getting those awesome hops, right? They would not be jumping nearly as well as we see them in those recordings of astronauts. Smiley faces if that makes sense. So on the moon, gravity is actually less. It's less on the moon, which is why we weigh less, which is why we jump more. Looking good. All right, everyone, this is number 3 in your ticket. Go ahead, give me a green check when you have it saved. You have 30 seconds. Go, go, go. Oh, thank you. I was on mute. Thanks, Amanda. I was like, why can't you hear me? Okay. All right, just need a few more green checks. Amir, David, Dree, Joseph, Matt, Maxine, Rozzy, make sure I get your green checks. Let me know if you're having any issues. Want to make sure I can help you out. Awesome. All right, let's keep on going. Okay, so here's the thing. Gravity, like all forces, causes acceleration, right? Remember, we learned this when we talked about Newton's first law, that forces cause acceleration. They cause things to get faster or slower or to change direction. They're changing the velocity. So gravity changes velocity. What I want you to think about is, let's imagine that you jump, okay, off of a one-story cliff into water, versus jumping off a 5-story cliff into water. Which one is going to hurt more? The 1-story or the 5-story? Which one's going to hurt more when you hit the water? Yes, the 5-story hurts way more. And why does it hurt more? What is going on that makes it hurt more when you hit the water? Tell me in the chat box. Why does it hurt more? To jump off a really tall building. Yes, the sudden stop from what? Yeah, you're higher, which results in by the time you hit the water, right? Yes, you're hitting it harder. So here's the thing. The higher up you get and the longer you're falling, the faster and faster you get, which results in a very sudden stop, like Tariq says, and you hit much, much harder, right? That force due to gravity is going to make you hit much harder the more and more you fall. So gravity, again, is making you speed up, making you go faster and faster. Take a look over here. After 1 second, how fast is this ball falling? Okay, take a look at our diagram here. So after 1 second, how fast is our ball falling? Take a look at this diagram. Let's make sure we can interpret it. So t equals 1 second. That means time equals 1 second. What's our velocity? What's our velocity after 1 second? Yes, 9.8 meters per second. Yes, make sure you include your units, no naked numbers, put some clothes on them. So after 1 second, we're already moving at 9 meters per second. Now, what happens after 5 seconds? Take a look down here. What's happening after 5 seconds? How fast are we now moving after 5 seconds? 5 seconds of falling is not a long time, right? 1 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000. Yes, it's 49 meters per second. Very, very fast. This is why if you go up to the top of the Empire State Building and you drop a penny, when the penny hits the ground, it can actually leave an indent. And they don't want you dropping things from the top of that building because if it hits a person, it can actually kill them. Because by the time it gets to the ground, it's been falling for so long that its force is extremely powerful and extremely dangerous because it's just moving so fast. It's accelerating so quickly. Smiley faces if that makes sense. Smiley faces if that makes sense. Awesome. Now, to keep this in mind, again, you're accelerating, okay? So if you weren't accelerating, no matter where you dropped something from, it would always hit the ground at the same speed, right? Which would mean if there was no acceleration, you could jump from the Empire State Building and you could live because you would hit the ground at whatever speed you jumped from and you would never speed up. Okay, so again, because we know we get faster, we know that there is in fact a force acting, and that force is gravity. This is proof that gravity is working. Okay, so question number 4 is asking you to match up these times with their velocities. So the force due to gravity on Earth is 9.8 meters per second squared, which means that every second you get 9.8 meters per second faster. Thumbs up if that makes sense. Every second you get 9.8 meters per second faster. That's what this means. Okay, so every second you get 9.8 meters per second faster. Okay, that's what that means. So you're going to go ahead and match these up. So at 0 seconds, you're moving 0 meters per second. 1 second, you're moving 9.8. 2, you're moving 19.6. 3, 29.4. And I think those are all of them that it asks you to match up. Okay, so go ahead and answer question number 4, match those up correctly. I'm going to go ahead and give you a little bit longer on this one, so you have 45 seconds to answer number 4. Ready, get set. Taking a little bit longer, so I'll give you another 10 seconds. All right, looking good. Let's get some green checks. Amanda, Amir, Andrea, Ashton, Danny, David, Dorian, Josiah, Michelle, Misael. Again, you're just matching up the times with the velocities that you see next to them, just like in this chart. Okay, so after every second, you get 9.8 meters per second faster. Awesome, looking good. Green checks, we're almost done. All right, looking good. All right, if you missed this, don't worry, it will be in the recording. Recording will be uploaded at 2 o'clock. So if you miss anything, just remember to write down the password and you can always go back to it later. Okay, so here we go. Our objective for today, we talked about friction, gravity, mass, and weight. We also welcomed our new cohort 2 students, so that is why the beginning of the class was a little bit longer. But you guys did excellent. Here's the deal. So especially for my new students, you do need to know this. The attendance ticket questions you just answered are actually also the answers to the quiz questions. So I'm going to send you today's quiz. All right, let me go ahead and get that to you. So here is today's quiz. Here's the link to it, the 3A quiz. If you open that right now, you can go ahead and just really quickly answer those questions using our attendance ticket and then submit them at the same time. So just really quickly right now, take 3 minutes after class to get that done and ready to go. And then you're all done for today and you have nothing else to do for me for today and you are all set. Smiley faces if you feel good about that. Although new students, remember there is a survey. So if you have time today, please get the survey done. It's not due until Friday though, just so you know. Awesome. You are also on top of it. Here's your last word. Thank you so much, everyone, and I will see you later. Again, this is the last word, number, I think, 5 in your attendance ticket. Bye, everyone. Have a wonderful day. Again, if you missed anything, it will be in the recording. If you need anything else, let me know. But otherwise, I'll see you later. Please log out. I do need to go to my next class. Bye, everyone.